Hello, in this tutorial I'll give you a very fast overview about protocols. So the idea is to explain to you how does it work, the REST, SOAP, SSE, WebSockets, HTTP, FTPS and other protocols as RPC, AMQP, DNS, SMTP, push. So basically I will write in here the different layers, so then you can understand how does it work on the networking level. So every protocol has their own lowest protocol, so I'm starting from above to the bottom, from the top to the bottom. So below here we have MTLS in here. So basically we have here are the representational protocols. In here we have the application protocols. In here we have the secure protocols. In here we have the transport protocols, which are the TCP, UDP and ICMP. Then we have the IP and the IPSEC protocols. Then we have Ethernet and Wi-Fi. This is the link protocol, and then here we have the physical part, which is the hardware layer or the hardware layers. And in here we have the network protocol. Okay, so basically these are the multiple different layers, the protocol layers that we have. So I'll explain to you all of them. So I'll start by these two. So Ethernet and Wi-Fi is done through MAC addresses. Then we have the IP layer, where basically connects two endpoints, where we have the source, this destination IP, and we have the source IP and then the destination IP, so we can send packages between these two endpoints. So endpoint to endpoint through IP. Then we have the IPSEC, where all the packages are encrypted, so encrypted packages. So we can put here packages. So this IPSEC layer basically encrypts all the messages, the packages, and this is done through the OS, where both endpoints, both OSs needs to be configured to have the same keys, so they can encrypt and decrypt the correspondent data. So all the connections that are going through the IP, all the packages are encrypted, so no one can see it. So this is encryption, very secure encryption in the network level. Then we have, from the transport, we have TCP, where the TCP we have more headers than the IP. So basically how this works, so basically the client sends a sync request to the server answers with the sync acknowledge request. Maybe like this, and then the client sends back an acknowledge saying I received that sync. So from here now we have the what we call the TCP and shake. Then we have UDP, where basically this is just one connection. So where basically we have the client that makes a request to the server, and from this point it is the server that's sending multiple different requests without any confirmation if the client receives it or not. So this is not, there is no handshaking here. So this usually is used for broadcasting. Then we have the ICMP, where basically this is the Internet Control Messaging Protocol used to ping and for trace routes. This is just one round-robin connection, where basically if we have the client and server, basically what happens is client pings the server and server answers back and automatically receives the answer from the server. So this is just one ping pong, one round robin connection. There is no acknowledge, no ACK messages in between. So this is related with the transport layer. Now the secure layer is a layer that runs over the TCP, so MTLS or TLS. So TLS is known as also SSL, or in the old times as SSL. So basically this is the transport layer security, or the server secure layer, where basically, let me explain. So let's give here some spaces. So we have the clients, we have the server, where basically in here the client sends a client hello saying I want to create a TLS connection with you. So the server sends a server hello, where it sends certificates. Then clients, this, as a matter of fact, this doesn't work as exactly by this order, but basically then the client sends the cipher list that he allows, the allowed cipher lists. Then the server sends back saying, oh, I can use these ciphers that you also have, so you can choose either both. Then the client creates, it sends random number to server, server sends random number also. So most of these requests here are done in just one connection. Doesn't need to be in all these multiple different connections between them, depending on the TLS version. So we could say that client sends client hello, sends the cipher list and random number, and server sends hello, sends the certificate, is ciphers that he allows also, and is random number. Something like that. Then, just to make the life easier here, so we can understand this easier. So then the clients, based in the server random number, let's put here server random number plus the client's random number plus a pre-shared key that he'll create based in the cipher. He'll create, well, as a matter of fact, based in these numbers, and plus the, this is the public key from the certificates. So basically when the server sends a certificate, the certificates are done based in a public and a private key that the server stores internally. So the certificate contains inside the public key, so that's when the client receives the certificate, it can extract the public key, and then it automatically creates here a random number that already shared with the server and receives another random numbers from the server. So it mixes all these three and creates, based in the cipher that you choose, it creates a pre-shared key. This is from the client side. So this is from the client side. So let's put this here. So there is no connection until then. Then the client sends the pre-shared key that he created, but encrypted with the public key that he has from the certificate, the public key from the server side. So when the server receives these requests, it will have an hash. So then the server decrypts these hashes with his private key, that is, he has stored this private key internally, and obtain the pre-shared key. Then, based in the random number that he has internally, that he calculated before, the server random number, plus the random number from the client that the client sends, plus this pre-shared key, he calculates a new shared key. Also, the client, from the client side, based in these two random numbers and the pre-shared key that he created, he will calculate also a new shared key. Then server sends back to client a new message encrypted with a shared key saying, can you read this? Something like this. And client decrypts this message with this shared key that he calculated before also, and answers back saying, yes, I can read, but this message is encrypted also with his shared key. So we can put this, then client sends this back. Then the server decrypts this message and sends another message saying, I'm ready. Another encrypted message. So all this encrypted message, so the client sends this encrypted message based in his shared key. Based in his shared key. And then client decrypts this message with this shared key. And the TLS handshake is done. So from now on, any connections that the client sends to the server or that the server sends to the clients, all of these will be encrypted with in here with the client shared key, and in here with the server shared key, which are the same but are not shared. They were not shared through the network. So based in the same data, both of endpoints were able to create the same shared key to encrypt and decrypt the data without sharing that key through the network. So this is TLS. You have diagrams on the web that you can search for it, so you can understand it. So what is MTLS? So this means mutual TLS. So in the TLS, only the server contains a certificate, a public key and private key. In MTLS, both clients and server will have their own certificates, public and private keys. The idea is, so the same thing that will happen here basically will happen very similar in MTLS. So basically the server share its certificates with the client, so the client can generate the shared key, and the client will send his certificate also to the server, so the server can create his own shared key. So every time that the client sends a message to the server can decrypt that message based in the shared key that he created with the client certificate. Every time that the server sends a request to the client can decrypt that information based in a shared key that he has from his side that he created based in the public certificate. So from the client side is exactly the same thing as it is in here. So in MTLS, the client shared the random number, the server shares the random number also and shares the certificate. Additionally, in the MTLS, what happens is that the client shares also his certificate, which is different from the server. So each of them have their own certificate. Based on that, each of them will create it will not be the shared key, but will be their own key to encrypt messages between them. So that's basically MTLS. So it's basically a much more secure protocol. Is basically public and private key, where in this protocol basically you encrypt data through the public key and you decrypt to the private key. In this case it's not exactly like this, because then each point it will create their own keys based in this data, and then based in that they'll encrypt and decrypt the data based in that unique key. So then we go to the application layer. So let's put here application layer. So let's go HTTP. This is hypertext transport protocol, if I'm not mistaken. Protocol. HTTPS is HTTP with TLS. And then we'll check the rest of the protocol. So basically HTTP is a protocol where everything on the web is based, where basically we have also different headers than the TCP headers and the TLS. So where basically in here we have headers like get, post, put, options, header, trace, connection and other headers, where basically allows us to sends information to another endpoint with some specific data, which in this case will be text data, or depending of the content type, it could be binary data also, obviously. So this is the HTTP protocol. HTTPS is, so it sends, the difference between both is that this information is not encrypted when it's sending through the network. If you have TLS, basically each side of the endpoints, it will encrypt the message and then decrypt from the other sides. Okay, then we have gRPC protocol, where basically this is remote procedure call protocol, where basically in here one endpoint sends to another the action to be the action that should run in the destination endpoints. Basically, let's say that we have the server the server A and the server B, two servers, A and B. So the server A sends a request to the server B to execute a specific action, passing the specific action, the specific data, parameters, whatever. So this basically remote procedure calls is used for internal requests in the network, in the private network between two servers. Then we have, of course, that then all this data could use TLS also, where these connections will be made, all this information will be encrypted. Then we have AMQP, where basically this is the asynchronous messaging queue protocol, where basically we have two endpoints also, where one, so let's put here synchronous messages queue protocol, whatever. So one endpoint sends a worker and a list information, sends a worker plus the corresponding data, whatever, to another endpoint. Then the destination endpoint will save this worker in the correspondent queue, basically the server A sends, I want to execute this specific worker with this specific data and save this worker in this list. So the other endpoints basically put this worker in the queue and then will dispatch this queue, usually based in some specific configurations, which basically is FIFO, first in, first out. So when this destination endpoint dispatches or releases a specific worker from this queue, automatically sends back that information that you already dispatched this worker to the first endpoint. So the destination endpoint sends a notification, let's call it notification message, a notification message to the source endpoint with a worker plus data information, saying, okay, now I have this worker with this data, so you can execute it. So then the source endpoint can execute this worker. Basically, this is used when you have, let's say that you have like 1000 workers to execute that you receive in a specific period, but your server only have 10 threads that can execute simultaneously. So you need to put that 1000 workers in a queue. But if you don't, or you create your own queue and it's you that's manage that queue, or you can have an external services, an external server also to manage that queue for you. So usually this is used in RabbitMQ, in Kafka, in AWS SQS. So services that basically all these services that will manage the queue for you, and automatically, so we'll save automatically that 1000 workers in a queue, and then it will send back each individual workers, so you can execute it based in the threads that you have available. So every time that basically, let's say that you have 1000, you only have 10 threads, so you execute the first 10 workers. So automatically you send 1000, you get back the 10 workers. After you execute that 10 workers, the other endpoint, it will send the next workers. So obviously that does not be 10 and then you need to wait for the 10 to finish to send another 10. No, like we are executing in the source endpoint 10. As soon as the first worker finish, you receive right away the 11th worker, or the worker number 11. This is the logic. So basically it's like a logic, is like a FIFO queue basically, where you are receiving multiple workers and automatically the queue to be shorter and shorter. So you don't need to handle this type of things internally. So you can do that with the external services. Additionally, what happened is that, let's say that then in the source point this worker failed, so you can send back to the queue, you can ask the queue to execute it again, you can put this in a dead letter also, where basically is a persistent type of file system log where you have the failed workers. So then you can re-execute later on, or you can save this in external database, whatever. So this is the AMQP protocol. Then we have DNS, domain name servers, where basically this is to get the IP for a domain, where in here, if you want, you can redirect requests through based in geolocation also. Then we have the SMTP, this is the email protocol, and then we have the push protocol, which basically this is the notification protocol, where basically the client subscribe to a specific service. So let's say that we have the client, we have the server that handles the notifications and the subscriptions, and then you have your client C. So the client subscribed in the client B for a specific service. The server B, C will have that specific ID of that subscription, and every time that the server B wants to notify that client, will send a request to the server B saying, I want to notify this specific subscription ID with this message, and that's third-party server, the server B, it will then send a notification to the client. That's the notification protocol. So client, subscription server, and your server basically. So this is like basically like this. As a matter of fact, the client, usually when the client subscribes to the server, the client sends the subscription ID to the server, to your server, so you can save that subscription ID. Then the server, when he wants to notify that client, sends that subscription ID to the server, here, and automatically the server will handle the connection to notify this client here. Basically that's how it works. There are multiple different of subscription types of servers, different types of protocols. Then that's where this can happen. But basically the push protocol, basically the idea is exactly this thing in a summarized level. Okay, then we have representational layer at last, where we have REST, SOAP, SSE and WebSockets. Okay, REST is only a representation layer. It means that this is the representation state transfer. Representation state transfer or something like this, where basically this is just HTTP requests with or for where the data is formatted in a specific format, like JSON, XML, whatever. SOAP is the Service Object Access Protocol, if I'm not mistaken, or Server Object Access Protocol. Service, I believe is service. So it doesn't really matter. So the idea here is this part. This is the important part, where basically this is like HTTP requests always, where basically all the information, where data is based in XML and objects are translated in XML. Basically this is a protocol where you have two endpoints, where you can't pass objects from a server to another server, where basically you can pass simple data or real object data. Then from the other side, the other side can translate that XML data into objects, and then can execute functions of that specific object. So let's say that you translate some objects. You say that an object will have this specific function. This specific function receives this specific arguments. So then in the other side, in the client side, you can call then that specific function based in the objects that you translated from that site. So that's SOAP. Then you have SSE. SSE is server sends events to clients or to other servers. Basically is a protocol that it runs over HTTP also, is HTTP requests, where basically the client, so let's put here clients opens connection to server via HTTP, and then be listening, and then the client is constantly listening for answers from server. Then the server sends back events to the client, so clients can parse these events and execute actions. So how does this work in a practical case? Basically the client sends a request to the server saying that he wants to subscribe to a specific service from the server side, saying that, let's say that we have a website where we are showing some stock indexes or some stock data values. so that values can change every second. So basically, when the client tells to the server, I want to subscribe and I want you to update me every time that there will be a change from your side related with this value. So then then the server, every time that something gets changed in the server will send that an event, that subscription service that the client subscribe to send that event with that specific data. So then the client from his side is saying, you will have, if the event is equal to update stocks, whatever, then automatically execute the specific action, goes to the specific HTML components, whatever, or go to the specific UI and update the corresponding value that I just received from the server. This can happen every second, or depending of the time basis that the server sends the requests to the server. So basically this is like so the server is a connection between server to client. So let me put here, so this is the connection to server to client. This is not, there is no interaction between client to server, so the client subscribes to the specific service, to a specific event on the server side, and then is the server that always sends the information to the client. Then the client only needs to update and show to the user, to the end user, that specific information that the server sent. So this is the SSE protocol. And then we have WebSockets. WebSockets basically is a connection between clients and server based in HTTP, also where the connection that is done between client and server is based in HTTP, but after the handshake, after this connection be done, then both clients and servers will talk through TCP requests. There will not be HTTP, there will be TCP requests, where basically the client can send data to the server and the server will read that specific data, raw data, and the server can send data to the client and client can read that raw data. Usually what I do is that information, usually you can pass through JSON or through XML, whatever the structure that you want to put, and then in that JSON structure what I have is I have a specific event, the name, or a specific action, and then I have the data corresponding to that action. So then each side can read that specific action or event and then can execute specific logic based on the data that he also received. So let's say that in here I can have, if the client if the event that it receives, if it is update stocks, then I'll update that specific value in that specific HTML element. Very similar with SSE. The difference is that I can send also messages to the server side, and then the server side can say, if the event that the client sent me, if it is something like register a new user, so then I'll insert in my database that specific user, something like that. Or let's say that if we are talking about in an e-commerce websites which have WebSockets, where we have available quantity for each product. So let's say that the clients did a purchase, which means that I need to decrease. So if the clients will say, I purchase this product, so the server needs to decrease the quantity, the available quantity of that specific product, and automatically it will update all the other clients with that new quantity. So then the client will say, if the event it is update product quantity, I'll receive the product ID probably and the new and the corresponding new quantity. So then each client can update its UI. So the server, the way that it does this, it will automatically broadcast this event to all the clients that he has registered, and it will informing them, passing them this specific data through TCP requests. So HTTP is only used to create the connections between these two, the clients and the server. So basically this is like a first overview about how the protocols work, about representational layers, application layers, secure layers, the transport layer, the network layer, the link layer, and physical layers we didn't go through because this is like hardware. It doesn't make sense, but from the protocol levels we can see that all of these protocols, they have a reason to be here, and most of them you can see that they have other protocols below. So this is important so you can understand all of these. So every time that you are deploying your app or preparing some server architecture, you need to understand all the constraints about this.